Scientists have finally discovered a crucial clue to dark matter. This discovery could rewrite physics textbooks. The Fermi satellite detected an anomalous gamma-ray signal at the center of the Milky Way. The data show that 85% of the matter in the universe is silently passing through your body. At this very moment, trillions of dark matter particles are passing through your brain. Even more astonishing, new research has found that the distribution of these particles in the universe is not random, but instead forms a precise, network-like structure. Physicists have calculated that dark matter particles theoretically remain inside the human body for a brief 0.0001 seconds. This number shocked the entire scientific community. Chinese scientists built a laboratory 2,400 meters underground at Jinping Mountain, specifically to capture them. Some physicists have proposed a bold hypothesis, that while we are observing dark matter may also be observing us in some way. Did you know? The chair you are sitting on, the screen you are looking at, and even your own body, together account for only 5% of all the matter in the universe. So where did the remaining 95% go? The answer is dark matter and dark energy. Dark matter is extremely strange. It cannot be seen or touched, it emits no light and absorbs no light. Not even X-rays can pass through it. Yet it undeniably exists. Because without dark matter, the entire universe would have fallen apart long ago. Imagine this. The Milky Way contains 400 billion stars rotating at high speed. According to Newtonian gravity, these stars should have been flung away long ago, but they were not. After calculations, scientists found that the Milky Way must contain dark matter with 10 times the mass of visible matter to generate enough gravity to hold these stars firmly in place. Even more outrageous is the bullet cluster discovered in 2006. After two galaxy clusters collided violently, scientists used gravitational lensing observations and found that dark matter and ordinary matter were completely offset from each other. Ordinary matter slowed down due to electromagnetic interactions, but dark matter did not. It passed straight through. This was the first time humanity directly saw evidence of dark matter. This discovery completely silenced scientists who doubted its existence. So what exactly did the Fermi satellite discover? From 2008 to 2023, this satellite continuously monitored the center of the Milky Way and detected a spherically distributed gamma-ray signal in the high-energy range of tens of giga-electron volts. This energy is about 20 times the mass energy of a proton, far exceeding the energy scale of X-rays. After analysis, scientists found that the shape of this signal perfectly matches theoretical predictions of a dark matter halo, with a statistical significance reaching an astonishing 13 to 19 sigma. You should know that in physics, the standard for confirming a discovery is 5 sigma. This result is overwhelmingly decisive. More importantly, these gamma rays are very likely produced when dark matter particles collide and annihilate. When two dark matter particles collide, they instantly convert into energy, releasing high-energy gamma rays. This is most likely to occur at the center of the Milky Way, where dark matter density is highest. But this is not the most terrifying part. Scientists have calculated that, at this very moment, hundreds of millions of dark matter particles per second are passing through your body. They do not interact with your atoms. Like ghosts, they pass straight through your skin, muscles, bones, and brain. But here is the problem. If they truly do not interact with ordinary matter at all, then how could the Fermi satellite possibly detect them? This means that dark matter particles occasionally interact with something, but this interaction is extremely weak, and the probability is incredibly low. Chinese scientists built the world's deepest dark matter detection laboratory, 2,400 meters underground in Jinping Mountain, Sichuan, precisely to capture these 1 in a trillion collision events. The design of the Jinping laboratory is nothing short of an engineering miracle. 2,400 meters of rock can shield against 99.9999% of cosmic ray interference. Here, scientists use 300 tons of liquid xenon as a detector, waiting for a dark matter particle to collide with a xenon nucleus and produce a faint flash of light. This experiment has been running for several years. During this time, they discovered a strange phenomenon. The detector was contaminated with an extremely tiny amount of tritium. There are only 20 tritium atoms per kilogram of xenon, while the same mass of drinking water contains 5 trillion. This means they built one of the purest detectors in the world. But even so, they still have not confirmed a direct signal from dark matter particles. Why is dark matter so hard to catch? Because scientists may have been looking in the wrong direction from the very beginning. For the past 30 years, the physics community has placed its bets on the WIMP theory, weakly interacting massive particles. These particles are predicted to have masses between 100 and 100,000 giga-electron volts, and should theoretically be relatively easy to detect. But all experiments worldwide, from the LUX Zeppelin experiment in the United States, to Xenon in Europe, to Panda X in China, have found nothing. The LUX Zeppelin experiment used 7 tons of liquid xenon underground for 280 days, increasing sensitivity by 5 times, and still found absolutely nothing. This has led more and more scientists to question whether dark matter is not WIMPs at all. It might be axions, dark photons, or something we cannot even imagine. There are even more radical theories. Some scientists propose that dark matter may possess some form of information processing capability. Think about it. Dark matter makes up 85% of the matter in the universe. It permeates the entire cosmos, forming a vast network structure. If dark matter particles can interact with each other in some incomprehensible way, could they form a universe-scale neural network? This sounds like science fiction, but studies in 2024 show that the distribution of dark matter is not completely random. On cosmic scales, it forms delicate, filament-like structures, and the process that creates these structures is far more complex than predicted by cold dark matter models. Even more unsettling. If dark matter really is observing us, what is the purpose of that observation? The latest data from the Dark Energy Spectroscopic Instrument in 2024 show that the expansion rate of the universe is not as constant as previously believed. Dark energy itself may change over time, and may even reverse or disappear. What does this mean? It means the evolution of the universe may not be a random process, but guided by some mechanism we do not understand. Dark matter and dark energy account for 95% of the universe's mass energy. If both of them are changing, then are we, the remaining 5% of ordinary matter, just a byproduct of this vast system? Now let us return to the original question. Have scientists really discovered dark matter? The answer is both yes and no. Yes, the Fermi satellite has indeed detected anomalous gamma-ray signals, and China's Jinping laboratory is gradually narrowing down where dark matter could be hiding. But no, because these findings are still not enough to say we have found dark matter. History has shown many times that scientists thought they had found dark matter, only to later discover pulsars, supernovae, or other astrophysical phenomena. In 2024, some scientists even proposed that dark matter may not exist at all, and that all these phenomena could be explained by modified gravity theories. But regardless of what the truth turns out to be, one thing is certain at this very moment. As you are reading these words, trillions of dark matter particles are passing through your body, through this city, through the entire Earth. They have existed since the birth of the universe. They witnessed the formation of the first generation of stars. They witnessed the birth of the Milky Way. They also witnessed the emergence of human civilization. And even now, we are still desperately trying to understand what they truly are. Perhaps one day, when we finally understand dark matter, we will realize that the ones being observed all along were actually ourselves.